Today we are going to talk about the Pythagorean theorem. The section is called Apply the Pythagorean Theorem, which some of you know really well and use already. So for some of you this will just be a good review. Some people have. Alright, so this is called Theorem 7.1. It's called the Pythagorean Theorem.
Wait, is this the one with right triangle?
Correct.
Oh, yeah.
This only applies to right triangles. So I'm going to put that in a star, and I'm also going to highlight it, because that's really important. If it's not a right triangle, you cannot use this theorem. So we're making the assumption that we have a right triangle. So if we have a right triangle, the side across from the right angle is called the hypotenuse. The other side is called the leg. So I'm going to call this leg 1, leg 2. It doesn't matter which one you call leg 1 or leg 2, and it doesn't matter how you put leg 1 and leg 2 into the formula that I'm going to give you right now. But the hypotenuse is the one that matters the most. So leg 1 and leg 2, you can flip-flop them if you want. So what the Pythagorean theorem says is that the measurement of leg 1 squared plus the measurement of leg 2 squared equals the hypotenuse squared. So again, like I said, if you flip-flop leg 1 and leg 2 right here, so you had leg 2 first, leg 1 second, doesn't matter. Okay? Yes?
I've always wondered, but could you just do leg 1 plus leg 2 equals hypotenuse?
No. You cannot. That's a good question. If you take the square root of both sides and you try and... Here, I'll show you why this doesn't work. He asked me, can you do this? Is this okay? Leg 1 plus leg 2 equals hypotenuse. And the answer is no. Okay? The reason is this. Let's say we have leg 1 is 3. Leg 2 is 2. Okay? I'm going to show you why this doesn't work. Yeah. So, the theorem says, so this is the Pythagorean theorem. This is what the answer should be. The Pythagorean theorem says we say 3 squared plus 2 squared equals the hypotenuse squared. Usually we call that c squared. So you'll also see this as a squared plus b squared equals c squared. Okay? So, we get 3 squared is 9 plus 2 squared is 4 equals c squared. 9 plus 4 is 13 equals c squared. And then we take the square root of both sides. Because you're talking about a length, you don't have to put a plus or a minus. You can leave it as a plus because the length has to be positive. So c equals square root of 13. So if this had a leg of 3 and 2, legs of 3 and 2, the hypotenuse would be c. Now, the question was, can you say leg 1 plus leg 2 equals hypotenuse? And the answer is no, because what do I say with 3 plus 2 equals what? 5. Is 5 the same as square root of 13? No. So, since they don't, not sort of, that they're not at all. So, since they don't match up, you cannot, like, take the square root and get rid of those squares. That doesn't work.
Okay. Does it work sometimes?
It may work sometimes, but you should never use it.
Okay.
It'd be a fluke. Yes.
So what if the L1, L2 is a square or a rectangle? Would that work or not?
Yes.
So if it's a rectangle, you could use it?
Well, it's not going to be a rectangle. It'll be a isosceles triangle, right?
Oh, okay, but you could
So, I'll do an example. I mean, we might as well do an example, right?
Yeah.
So, here's an example. Yes.
Is all of that right below the triangle to say why no?
Well, this one shows, this is an example to show how you would get the hypotenuse. But this one is also to show, no, that they don't equal each other. Yeah, so it does double work. It shows you how to get the hypotenuse, and then it also shows you that they don't work, that this one doesn't work. Okay, so someone wanted to know if we have an isosceles right triangle, will it work? So the answer is yes. Let's say my isosceles right triangle has a length of 2 and 2, and we want to know what the hypotenuse is, C. So then we just put it in our formula. 2 squared plus 2 squared equals C squared. 2 squared is 4, plus 2 squared is 4 equals C squared. 4 plus 4 is 8 equals C squared. And then you take the square root. Now, you guys should be able to reduce the square root. We learned how to do that last chapter. Take 8 and you get 4 and 2, and 4 and you get 2 and 2, which is square root of 2 times 2 times 2, because you take all the ones at the bottom of the factor tree. And what happens? What do you do? How do you do this? Yep.
All the pairs of 2's, you cross them out and put a 2 on the outside.
Good. So if you see a pair, you cross it out and you pull on the outside. So I'm going to say there's one pair there, and there's one lone one left over. So 2 root 2 is my final answer.
And that's all you have to do, like no more.
That's correct.
Okay.
Now, this is also a special right triangle. We'll be talking about it later. It has special values to it. So it's good that you know that. The other example I want to do is, let's say we don't know one of the legs. So let's say we know this leg is 5, and we know that this is, I don't know, 13. Actually, let's make it 12, so that most of you guys can do it in your heads. Alright, and then we'll call this side A. So, we still want to set up the formula in the same way. So leg squared, so A squared, plus the other leg squared, which is 5 squared, equals 12 squared. So then we have A squared plus 25 equals 144. Now what do we do? Subtract 25. So we get A squared equals 119. And then what do you do to finish? Square root. So we have A equals square root of 119, and I believe, I'm not positive, but I'm pretty sure that this doesn't reduce at all.
No. It doesn't, because it's 119. 19 can't reduce.
Are you sure about that?
Yeah.
Well, 119 is 7 times 17, but those are both prime numbers, so, and they're not pairs, so you wouldn't be able to pull anything out anyway.